Hi, so welcome to my tutorial of Autodesk Inventor and what it can do for you. So I'm going to be using some examples, one of them being the Skills Robot for 2019 design that the Robotics Club at Northern made. But I'm going to start by showing you the workflow. So Inventor has a very simple workflow. You start with sketches. So I'm going to make a sketch. Let's say I want to make an L. So I can create my L like so. Just a 2D version of it. And then when I'm done this sketch, I can add more to it. I can do circles, arcs, rectangles, and lines. But often lines and rectangles are all you really need to use. Maybe the occasional fillet, but that's about it. When you're done doing that, you click Finish Sketch. And now you've got this plane. And if you click the Extrude button, and let's say we want to make our L 0.15 thickness, okay? And then you click OK. And now you've got a complete 3D object. So, for example, something more complicated you can make is this. So this is the first floor of our chassis on our robot. So let me just zoom out so you can get a better view of that. Like this. And you can rotate it very easily with this cube that it provides. And then, so you can, okay, so you can get front views, side view, top view, pretty much any view you want just by rotating this cube. Now, here's another example of a part we created. So this is the top floor. Now, these are parts, right? You create your parts from a sketch, like the one we just made. Now, what you can do is you can turn your parts into a subassembly. So, for example, this is one of the subassemblies on our robot. This is for the ball launcher. And basically, this right here, it's got a bunch of parts on it. It's got motors right there. It's got the wheels on top of the motor. And then it's got this, which is a bracket that holds our hopper. And then here is where the piston's mounted. This is a counterweight, and these are the servo motors to adjust the angle. So this has many parts included in it, but it's not the final assembly, so we call those subassemblies. I've got multiple ones. I've got this. This is our shovel assembly. It's got pistons, servos to rotate the shovel, and the shovel itself. We've got this battery holder, motors, and more. Now, when you have all your subassemblies, you can create them into your main assembly. So this is the main assembly for our robot. It's very complicated. You've got air compressors, wiring, which I'll go into a bit soon, and every other part I want to add to it. I can use all these different tools on it. The joint tool to hold things together. You can add rotational joints, sliders, cylindrical, planar, and ball joints, depending on what you're building. You can also add different constraints, and if you go back into the parts section, you can adjust the materials of what you're using. And everything auto updates as you go. So let's say I want to use copper. So I'll click on the object that I want to make. One second. So I'll click on the object and then I'll click copper, and you'll see it'll update the color and possibly the texturing depending on how advanced your graphics are on the computer. And it will then, in other tools that I will explain later, it will allow you to do stress analysis. So Inventor is really good for creating complex mechanical assemblies because it's great because you can put it in 3D and you can have multiple different people working on the project at once by giving them different parts to build, and then they can all easily be updated into the main assembly without much complications like you would occur in AutoCAD. So what's really great too is you can take your 3D model and you can turn it into a orthographic drawing without really having to do any work. You click Base and then you select the file that you want, and then once you add your base, you click Projected, you click on what you want to project, and you can project anything you want in different angles, so you can get all the different views possible. Another advanced feature, which is not as relevant, but some people might like, you can animate your assemblies, which can be useful for presentations. So with Inventor, it allows you to integrate any electrical components. So if you're ever doing any projects that require electricity, you're going to find Inventor very useful. Using in the environments panel, I'm just going to open the current harness down here, but you would click the cable and harness. You can edit all the wiring on board. So right now you'll see I've got all the wiring. You can run cable routes manually, or it will automatically route the cabling for you. And when you're working with the parts, you can create pins. You'll see the little yellow markings right there. So those are pins. And then you can connect all your wires to it and have them go wherever you need them to go. You can change the colors. You can do a lot with Inventor for that. And I find it really, really useful when I'm dealing with any electrical projects. Another useful feature of Inventor is its stress analysis tool. So I'm not going to show you that because it takes a long time to render, but what it does is it'll tell you the maximum load points, it'll show you bending and everything, so it's very useful for anything where structural integrity is important. There's a lot of other tools you can use. Let me just pull them up. So you can put in pins, bearings, V-belts, keys for example, the motor axle interacting with the wheel. You can add shafts, disc cams, for example, that you need in engines. You can do compressions for springs, torsion springs, O-rings, splines, and gears. There's so much you can do with it, and you can even use pretty much its AutoCAD feature within the drawing. And I feel like that makes it one of the best softwares you can use for any project, in my opinion.